Twitch. It's yeah, okay.
I wanted to join you guys' group so I can get all this.
Oh yeah, the Bitcoin Grove group.
Bitcoin.
Grove.
Oh, yeah.
Grove.
It's a
Telegram
Yeah.
group
Bitcoin Grove.
called, Bitcoin Grove. I think it's
Okay.
T dot.
Odd. Let me do a test. Can I hear myself? Odd. Yeah. Let me do a test. I don't want the feedback. That's probably gonna come. No one really tunes in, but I keep it open. It records it also.
But they can.
They can. That's in the future they could, right? They,
Huh?
they can find it in the future.
All right, yeah, they can find it in the future. I've been recording most of these. I only have one uploaded on Twitch.
Have you tried doing YouTube?
I could try YouTube. I haven't, but
Let's do
yeah.
YouTube.
Yeah.
You never know.
Yeah. Next time we'll be streaming on both YouTube and Twitch.
Is the link on the meetup? It's on Telegram.
Link to.
But no, actually, I don't think the stream link is on the meetup. I'll comment that on
All right. Well, I'm starting. Understanding Bitcoin source number 9. I'm Randy, of course, and there's my TA, Michael, and feel free to ask questions. It's a Socratic style, so I like to ask questions from you guys, and it's a dialogue. So, mining is something pivotal. It's part of the Bitcoin network. It is essential, or else Bitcoin doesn't work. And here's why we Bitcoin and the part that mining plays. So, mining is publicly verifiable. That's how Bitcoin is publicly verifiable, because all the miners have to broadcast their blocks to get accepted, so they can claim the Coinbase. Bitcoin has strong ownership guarantees. It's practically immutable, and it has a 21 million cap. Now, the things that mining kind of contributes to is this practically immutable part and the 21 million cap, right? Where they kind of, they ensure that the proof of work that's put on each block can't be, I guess, equivocated. That's what I'm looking for. Without putting down a lot of energy, and of course failing, because the majority doesn't play by fake rules. So yeah, I was gonna go into this and assembling blocks. I wanted to go over what a block is. Now, a block is composed of a block header, and the block header contains all of these different things. So a block is actually versioned. If you guys knew about block versions, there's a part of the block where you actually link the hash of the previous block. You have something called the hash Merkle root, which is you make this thing called a Merkle tree out of the transactions in a block, and then you pretty much process all these transactions into a function, and that's the Merkle tree construction is part of that function, and the root is something that commits to all the transactions in the block. And end time is a timestamp that you put on the block. You can kind of fudge this timestamp. It doesn't have to be super exact, although there is this thing, I think it's called network adjusted time, something like that, where you can't be too far away from the majority of the nodes of the network. And end bits, there's, I can get more into that later, but it has something to do with the target, which is what your hash of the block has to be lower than. And then there's, of course, something called your nonce. And your nonce is a random number, typically, that you use to try and mine a block. And the end nonce is the thing that usually you change. You also kind of change the end time, but we'll get into more of all of that. So what does a serialized block header look like? And this is in hex. A lot of Bitcoin data is represented as hex. But that initial green part, right before the end version, is how much space the version takes. All the following green is how much space the hash of the previous block takes. After that, so on, like the hash Merkle root and end time, blah, blah. But I just wanted you to get an idea of how much space each field takes proportionally of each block. And also I want you to note how small that end nonce is. So, yeah, which can be a problem and is a problem, but it's worked around. It's kind of not also a problem. So what does a serialized block header look like? So this is an actual block that I had, and these are filled with real values that you can go and look up, and it's kind of like a compact piece of data. And again, this is just the header. This doesn't include the transactions, but the block header is gives you a summary of the data that's in the block through that Merkle root, right? Because the Merkle root commits to all the transactions in the block.
Guys, a question.
Yeah.
So if they put other information onto the block, like when they put those messages, where does it go?
The messages. I'll go into. I have slides also, but yeah, I can answer the question as well right now. But
I'll let you flow.
okay, but it's stored in the Coinbase transaction, and I'll go into that as well.
Wait, so why do they call it serialized block? Is it just because it's in hex, or is there some non-serialized?
Yeah, it's in hex. Just that's a serialization method that was chosen for this. But of course, if you really wanted to, you could represent this in base64 or whatever. But hex is kind of the standard for Bitcoin things.
Mm-hmm.
So if you use Bitcoin Core on the CLI, typically it accepts hex for those RPC commands that you make.
Mm-hmm.
Yeah.
Hex is a language?
It's a data representation.
Oh,
So
okay.
like every 2 characters is a byte.
Okay, 2 characters.
Yeah.
Like a number system too.
Yeah. There's so like a byte is made of 8 bits, and bits are zeros and ones. And then when you change the bits in a byte, you get like different numbers.
Mhm.
So yeah, each 2 characters represents a specific value of a byte.
Got it. It's very large. It's a very large. It could be very.
Yeah, the more bytes you add, like the bigger the numbers you can make are, because you could compose these bytes together and make larger and larger numbers. Yeah, and I'll get more into that with respect to hashing as well. But how are transactions selected for a block? So whenever someone broadcasts transaction from their wallet, it gets relayed to a node and placed in a waiting area before it's accepted into a block. And the area is called the mempool. It's a shorthand for memory pool, and I kind of went into this last time, and it's called the memory pool because as your Bitcoin node is running, you keep this information in memory, which kind of means you store it like in your RAM. You also end up committing data from the mempool to your hard disk, but during execution, you do have this stuff loaded up. So that's why it's important that people have sane max mempool sizes, because if they have mempool size configured that's bigger than the RAM they can support, it could crash your node. So, and another important thing is the first transaction is always the Coinbase. So that is an important detail. Transactions after the Coinbase are greedily selected from the mempool according to their individual or package fee rates until the block weight is close to the limit. And I think I'll go into these things like fee rates and weight, but if I don't, I'll circle back. Everything makes sense so far? Yeah.
Like getting a little bit. Some of the I don't understand the Coinbase.
Okay. Yeah. So I can explain the Coinbase because I honestly don't remember what I put in all these. So yes, it's a good question. The Coinbase is a transaction that is required for every block. And what you do in this Coinbase transaction is, or as a miner, if I'm like mining blocks, I can create this Coinbase transaction and allocate freshly minted Bitcoin to address of my choosing. And
That's where you put the miner reward.
Oh,
yeah.
Oh, I see.
You could mine it. Actually, we played a game and like some people like forgot to specify the Coinbase transaction.
Yeah.
Oh, so if
So
you
that
don't
means the fees anybody could, or I guess I don't know. if
Anybody
they
can grab? It's
I don't know.
open.
Can they?
Well, so
At least you don't get them.
Yeah, you always need the Coinbase transaction. Now, whether you decide to make the coins claimable or not is kind of up to you.
For the transaction fees only, not for the block reward.
The transaction fees get collected in this Coinbase transaction as well.
Oh, okay.
So it's the block reward and the transaction fees. But yeah, if you misconfigure your Coinbase transaction, or like you
So
don't,
everything's manually inputted, all these things.
there's programs that like do it for you, but sometimes you get a mining company that's very ambitious and they want to like try out this new script. So like all addresses they're essentially get translated into something called script, and sometimes they want to try a new script and they mess up and they make their coins unspendable. Or for whatever reason they don't claim it. But yeah, you always need the Coinbase transaction. Whether you claim it or not is a different issue. But if you're using regular mining software that's off the shelf, it won't mess it up.
Do mining pools use the Coinbase? They just have a ton of like if a mining pool mines a block, they just all they have is just everybody that
Mhm.
helped, I
There's a
guess.
Coinbase and then the pool is responsible for taking, basically, there's a kind of trust in there.
Okay. There's no like automatic. Well, I guess you can't.
Automatic.
Like some mining pool that'll like somehow in the code be like, yeah, you're well guaranteed to get a reward.
I think there's something with the Stratum V2, which like reduces the ability for a coin, or sorry, for a pool to take more than they're supposed to take based on like the hash of all the different participants. Like they should be pro rata for the when you mine the block. show subsidy based on how much hash is provided. But I don't know if Stratum V2 is gonna solve all of that, but I do think pools that use that you can verify as a participant, they're actually getting paid.
But yeah, miners can, or the mining pool operators can rug you. If you have a miner and you join a mining pool and you're mining, they can rug you. Which is why some mining pools, like Ocean, they are looking into lightning payments, so they can give you like smaller payouts. Whereas like when you're part of a mining pool, so I've done something with Brains before, and you have to have this minimum threshold to withdraw, and that. Because otherwise it just may not make sense. You get paid for your
It's not
hash.
worth it to spend little transactions.
Right, exactly. But with Lightning, it can make sense again. But yeah, the address that's spent to in this Coinbase transaction is owned by the operator, and the operator takes care of the payouts to individual miners.
So the marathon, they ordered specifically what were the different types of transactions for the red or the green
Yeah, I know I forget what they were, but they
on their
did
logo?
they did look at mempool's categorization of things.
Yeah.
And then based on that, so it's funny because mempool's categorization isn't standardized, and I saw someone on Twitter saying it's funny that people might start standardizing mempool's view of things as almost new protocol. Protocol for viewing blocks. Yeah, what he's referring to is there's Marathon. I don't know if you've heard of this,
The
right?
company, the mining company.
Yeah, they've mined a block in a way such that in mempool's block explorer, it will display an M.
Mempool.space, right? Because it's not like the official mempool block explorer.
Yeah,
Like,
mempool's
mempool.space.
mempool's a product. Also, I'm not
It's
referring.
It's like a GUI.
I'm not referring to the Bitcoin mempool. I'm referring to mempool as the product, but mempool.space. Yeah, it's here. I might even be able to find it.
So somebody runs it like a private.
Yeah. Wiz, I believe.
Uh,
I believe Wiz is.
yeah, and there's a whole company. There's
There's different ways
other
to access the
employees.
mempool, like different ways. to-
Everybody's node has is constructing like a mempool for broadcasting. You're mining, you are hashing to be the one to find add the next block. So I think there's not one specific mempool, but
There it
this.
is.
Yeah. So this is what the mempool.space filter is displayed if you go by some sort of transaction type. It must have been. I don't know what it was. That's something we gotta figure out. It's what did they do to make these red and those green? Because it's just the two types, right?
Yeah, I know a lot of them are op returns. Maybe all of them. I forget. The transactions in this block did look
They
very
had to
weird.
probably pay to get certain. They probably mined a lot of.
I mean, yeah, they lost money from
Yeah.
not picking the optimal set of transactions.
Has anybody run the numbers and saw the cost of this?
I think someone did. They're maybe it's like 50 grand or something.
Oh, really?
And it's marketing, right? So.
Yeah. Maybe looking at it right now.
Yeah,
Really?
exactly. We're looking at it right now. More
Isn't that
marketing.
like a gang from Mexico or something?
It's a gas.
Yeah, maybe this is their shell company.
Okay.
Uh,
Good thing we don't have Windows.
Okay, yeah. How are transactions selected for a block? I was going over that. Oh yeah, back here I was talking about fee rates. So let me just explain fee rates now because I don't know if I put it in the slides later on. But every transaction is, I'm not going to say requires a fee, but every node has a policy on what they'd allow to go into their waiting area or the mempool. And policy dictates that there needs to be a minimum transaction fee that's put on any transaction that wants to enter their mempool. Now, you could make this fee as high as you want, given that you put as input into the transaction enough to pay for that fee. And fee is also implicit within a Bitcoin transaction. So let's say I had 1 Bitcoin and I wanted to pay Michael 0.5 Bitcoin. I would say, make one output where I'm paying him 0.5 Bitcoin, and if I don't make another output, the rest automatically goes to fees. It's just simplistic. I don't make an output to any miner. Yeah, so the fee rate is how much fee have you like delegated to whoever's going to mine your block relative to how big your transaction is. And your transaction sizes get bigger when you have more inputs or if you have more outputs. So if you use more UTXOs in a transaction, you're going to make a more expensive transaction. If you have more outputs, it's also going to cost more. Another thing is the thing that the address resolves to, these scripts, the bigger your scripts are, the more expensive it's going to be. So anything that contributes to the size of your transaction in terms of data is you're going to have to put down more of a fee for it to be attractive for miners to include in their block. Because the more space you take that they could put into a block, the less money they're able to get because the less transactions they're able to fit from other people. So they look at fee rates. And then the block weight is, they don't use hard sizes anymore. They use this thing called like virtual size, which is something that was made in SegWit. It's not super important right now, but it's some like size derivative.
They made it more efficient after SegWit?
Yeah, well they did this thing that allows us to have bigger blocks because they discounted this thing called the witness. So SegWit stands for segregated witness, and it's almost like the witness, this part of a transaction is not, the entire size of the witness isn't recognized. It's given a discount. So yeah, that's why they call it segregated witness. It's just this part that's, they made away from the transaction. It's also called segregated because the transaction IDs don't need to take into account what the witness is. But that's a different topic from the mining. I don't want to get too far away. So yeah, there's a genealogy to transactions. So I wanted to mention that let's say we have a transaction X that generates an output /UTXO that's spendable by the recipient. And when a recipient sends that output in transaction Y, so if I have transaction X that pays Michael and Michael spends the thing I gave him in transaction Y, it has to reference my transaction, right? Like it has to reference my transaction output because that's what his UTXO is. Now, my transaction X that I used to pay Michael is called the parent to Michael's transaction, which is the one he's spending from my output that I gave him. And together you get a transaction and its ancestors are called like these packages because they can be considered together when mining a block. And I think I might get into child pays for parent maybe.
Wait, what's called the package? Like, is the package only what's in the mempool, or like what? Like
No, it's a related transaction. So like if I have a parent transaction and a child transaction, that now creates this package.
But does it go all the way back to like the beginning of time, or does it only go back to?
Oh no, it's only refers to things like getting mined in the mempool.
Okay, so like if you have a transaction in the mempool that didn't get mined yet, but someone tries to use it based off of that one, then those two are a package.
Yeah. So if I made a transaction to you, and let's say my transaction was kind of hefty, I paid you and a whole bunch of other people, and my fee wasn't good enough for the size of my transaction, then you try to spend from the output of my transaction in a new transaction. Remember, that's transaction Y. If you have a fat fee compared to the size of your transaction, miners will look at your fat fee and say, we want this. But we can't get it unless like we mine Randy's transaction first. So now they'll consider us as like a package, and they'll mine me just because you're willing to give a fat fee to them.
Okay.
And that's child pays for parent, if you ever heard of that term before. Yeah.
And is it like how do they grab these transactions? How do miners decide when they grab which transaction?
They do it like pretty greedily. They'll see like,
They just grab it. They manually grab them.
Oh no, there's a program that like
Okay.
So they run a Bitcoin node. Well.
They decide like amounts, like minimum amounts, maximum amounts, profit amounts.
Right, their mempool has policies that say this is what we want to allow.
So I'm just like,
Oh no, yes, it's completely fine. Yeah, so they'll have like a Bitcoin node. So there's also a difference between like miners and mining pools we've gravitated towards mining pools, but let's say we're back in the day where everyone was like a solo miner. You'd have a Bitcoin node, and you'd have mempool as part of the Bitcoin node, and you'd set certain things as part of your policy on what you want to accept and what you don't want to accept. And then if you were running off-the-shelf like Bitcoin Core software back then, it would pick things greedily. So it'd say, what has the biggest fee rate? Let's put that first.
Okay.
What's the next biggest fee rate? Let's put that. People have made more complex logic for this selection process. So now they look at packages, for example. It's still kind of a greedy thing where it's all right, now we'll consider packages and individual transactions and get the things with the fattest fee rate for a package or a transaction. So yeah, I think, did that answer?
Yeah, you did, yeah.
Okay.
So if a miner picks transaction Y,
Yeah.
adds it to a block, but X is still not confirmed, like nobody's mined X,
Well, then they can't claim yours,
that's
an invalid
an
block.
invalid block?
Yeah.
Okay. Oh, wait, yeah, that's in the checklist. Okay.
Yeah.
So, because there's a script or a checklist that's okay, we have to check all these things to make sure there's a valid block.
Yeah.
Someone else broadcasted it, but if we're okay, all the transactions have to be referenced, they should have parents and stuff. But if X was never added to the blockchain, but someone sends you a block or Y is being used, where the heck is Y from? Then
Right.
say, okay, this is a valid block.
Yeah, it won't get accepted. So yeah, sometimes miners do make invalid blocks as well. Again, wasted money, because if you find
On
a
accident.
hash, yeah, on accident, they don't.
How
Yeah.
often does it happen?
Not very
It
often.
used to happen more often. Doesn't happen anymore, right?
Right. When the stakes, when the stakes are higher, people tend to not be too experimental with their mining software. But it has happened, and when it does, we all know about it. It's an
Oh,
event.
interesting.
Yeah, it's an
It's a
event.
big deal.
Right.
And
Exactly.
the network failed, kind of thing.
No, nothing fails. It's just maybe your Bitcoin Core node will receive this message and log it.
Okay,
and
just something didn't work. That's it.
right, and people will be like, "Oh, interesting," there's someone, there's a peer of mine that tried to give me a block that wasn't valid.
Laugh on the internet.
Right, exactly, and people laugh at you on the internet and say, "Oh, you wasted $50,000 or something," which happens. If you want to be innovative in this space and you want to try new algorithms, sometimes you take the risk of making mistakes, and sometimes these mistakes are very costly. So, yeah. All right, I think I'm done with that page. Policy alignment with mining incentives. So whenever you have a Bitcoin node, like I said before, this waiting area of transactions before it goes into a block, it's dictated by this thing called policy, right? And policy changes, so there's something called replace by fee, or Bitcoiners call RBF. And if I send a transaction to Michael, and I see that it doesn't have a high enough fee, there is a way for me to rebroadcast a transaction spending that same input, maybe with another input that helps raise the fee. And we call that replace by fee, because now the mempool of whichever node got my transaction will say, hey, he has a new transaction that he wants to replace that one with. We'll do it, but only if the fee's higher, so we'll do some checks. Okay, the fee's higher, we'll allow it in. And it's, yeah, but you have to make, whenever you do something like this, so replace by fee wasn't built in. It was something that was added to Bitcoin Core's policies over time, something that people could accept and adopt. But before they did that, they had to make sure it's incentive compatible, right? You don't want to allow people to put lower fees, because then it's what miner would ever run that, right? Allow transaction replacement for lower fees. It's just not game theory compatible. So RBF was something that was introduced, and I thought it was kind of interesting to mention. But RBF allows someone to use the same input with an updated fee, but the fee must have a higher absolute fee than the package it replaces. So if I replace a transaction, I can't just replace, I can't just make a higher fee than that transaction. I have to make a higher fee than the package. So if Michael put a fat fee on his transaction that he spent from my output, then I can't just replace my transaction, because the miner's going to be like, no way, I'll get so much more money if I take Randy's and Michael's. So for me to even try to replace my own, I'd have to put a higher fee. And they'd be like, all right, now his fee is high enough that it makes sense for me to ignore Michael's and allow this transaction to get replaced. And again, I put it here. This is so a miner is losing out on fees by including a transaction that will lose them fees. And it makes it only beneficial as they'll get more in fees while having less space consumed. So yeah, it's very interesting when there's discussion around policy because you have to make sure that it makes sense for miners to want to adopt it. And if miners don't adopt these policies, then things just won't get put into blocks.
So all the policy changes are only essentially just done for miners, right? Or no?
Oh,
it can be other things.
No, sometimes, yeah, as a node runner or someone who just runs their node, they don't want certain things in their mempool. So there's not one mempool, and I think Roz was saying that earlier. Any person who runs a Bitcoin node can choose their own policy. If I want transactions, I don't know, a good, maybe like with some minimum fee, for example, I could run my own node with my own policy, even if it's like handcrafted, to not allow transactions with a fee lower than some threshold, for example. In which case, now my waiting area in my node or my mempool is going to be different from everyone else's who's not running that same rule. And that rule is part of the policy. And now, why is this important? Sometimes my node might be connected to a whole bunch of miners. And maybe I'm these miners only node peer for whatever reason, I don't know. And if I change certain things in my policy, they won't get that information. Or let's say my node's connected to Michael's, and Michael's is connected to a whole bunch of nodes, and he just has me as a peer, because we're friends and he doesn't want to trust anyone else. And I start filtering my mempool, then the things that he gives to miners are going to be not representative of someone who has a more permissive policy on their mempool. So it changes dynamics on the network.
It's so dynamic, it's
yeah.
so diverse, right?
Yeah.
It encourages efficiency, right?
Yeah, well, everyone chooses the policies that they want to run. It gives everyone kind of like agency to affect the network in their own way. Now, people have debated how effective policy is. It's pretty effective, but one big issue that's been plaguing the Bitcoin community is inscriptions. And whether it's an issue or not, I guess that's debatable, but there is an issue with reconciling what we call the inscribers and the maxis who hate inscriptions. Inscriptions, I don't know if you've heard of these, right? The NFTs on Bitcoin. You put a whole bunch of.
I don't understand how it works, but.
Yeah, well, essentially they put data in a Bitcoin transaction that
a lot of data, right?
Yeah, isn't needed in any way.
Useless, right? It's
yeah,
essentially.
exactly.
It's better than NFT, at least it's in the blockchain, right?
Right. Well, they're making a landmark, right?
Yeah.
Of their data on the blockchain, and some people hate it, some people like it. And one big thing with policy that people are starting to take initiative of is they say, how can we prevent inscriptions from being relayed by our nodes? Because we know some people in our community are connected to miners, and maybe these mining nodes are only connected to people outside the inscription community. Then we have a say on what might get mined. But then miners, that's typically at odds with miners, because when you make inscriptions, they're typally willing to pay.
Money, right?
Yeah, they make more money.
Yeah.
They've clogged up the mempool, and they make sure blocks are full.
It's a weird thing. So it doesn't help the network at all, essentially, but it makes the miners a little bit more money, and it makes people a little happy because they get to keep. But there's no ownership of these inscriptions.
Ownership, there is a mechanism to determine ownership, but it has nothing to do with Bitcoin consensus. It is not enforced by Bitcoin. It's almost like if I gave you glasses and the glasses showed you something on top of, let's say, that mempool.space block that you're seeing, and it says names on it. It's an overlay view almost. So yeah. And the thing about inscriptions is miners like them because they get lots of fees. So they'd be disincentivized from connecting to nodes that are excluding inscriptions. And you could also bypass nodes. Let's say a miner said, hey, we never want to get filtered for inscriptions. And if you think you are, here's a web portal for you to give us your transactions directly, as long as it has a minimum fee. So there's other dynamics that could be at play. Yeah. Oh, I'll go to the next one. So block size and block weight. I mentioned this a little bit, but pre-SegWit, the block size was 1 megabyte, meaning that there's no more than 1 megabyte worth of transactions that could be mined every 10 minutes. Now, with SegWit, the block size limit of 1 megabyte was removed. and it was replaced with this thing called a block weight limit. And each transaction has a weight that's defined as this little expression here, and pretty much they discount the transaction witness by a fourth. So actually, I don't think this is like super complicated to go over, but you take 3 times the transaction size without the witness, and then you add in the transaction size with the witness. So you get 4 of the transaction sizes without the witness and 1 of the witness in that calculation. And then you divide it by 4 to get this thing called the V size. And then the V size is what's used in the fee calculation for the fee rate.
And for virtual?
Yeah, for virtual, because it's not you're not using the real sizes anymore.
Right.
You're discounting the witness first, because you added 4 of the transaction sizes without the witness, 1 of the witnesses in there, and you divided the whole thing by 4. So anyway, the block weight limit is about 4 million. I should have put some commas in here, which is about 4 megabytes is the biggest you could have a block. And transaction packages are added up until no more can be added without exceeding the weight limit. So it's by consensus, no one can make a block that's bigger than this weight limit.
So if there's too many transactions in the block and you get too filled and it goes to the next block?
Yeah. If you have too many transactions in your mempool, too much for one block,
It just waits a little longer.
Right. Yeah. Exactly. You could even make templates of what your future block's going to look like. So if you go to mempool.space, for example, they do that. They'll show you the current block that should be mined according to the majority rules that these miners use that dictated by Bitcoin Core, and they also show you what the future blocks are going to look like and what they're going to contain based off what they see in the mempool at that moment. So yeah, you kind of it's almost like you're setting up these blocks and then you're mining the latest one, but you have the next block ready. So right after this one mines, because you had so many, exactly, you're just picking up that next one. And as you get new things in your mempool while you're mining the first one, things are getting replaced to give you the most money as well. And then I had this piece of code, so I like to add some pieces of code. And this one is this thing called test package. It's in this class called block assembler, and it's just making sure that blocks aren't too big. Yeah, there's not much to that. So yeah, when you add packages, it checks this package size, and you don't want to exceed the max width of the block. Now, how are assembled blocks mined? So this mining process, I try to make it very simple by having a very empty slide, but you get the block header, and then you hash for proof of work, and then you broadcast the full block to the rest of the network with the hash that's below this thing called the target. And maybe I go more into it. Oh, yes, the intuition. So what's the intuition behind proof of work? Imagine 2 people, Alice and Bob, and they're flipping a coin until one person gets 10 heads in a row, and then the winner gets 10,000 sats. Do you think it's likely the person who will win is the person who did the most coin flips, right? So right, if I flipped a coin 10 million times and you flipped it 10 times, who do you think is gonna have the 10 heads in a row? And let's say it's within the same time range. Who's gonna reach it first? Clearly, my rate is faster, so I would probabilistically reach that. And that's kind of the intuition for mining, right? The more hashes you're able to do, the higher your chances of reaching some probabilistically unlikely outcome. And for that, it's hashing a block until it's below a certain number. Now, how about if right after there's a winner, they continuously start a new game? So let's say we start a new game. If as long as I'm the person who's flipping the most coins within a given period of time, or my rate of flipping coins is faster than yours, then I will be dominant. But if I let a new contestant, Carol, in and say she can beat the winner of the first coin flips, if she gets more 10-head streaks than the number of games played, does she have a chance? And it's yeah, she has a chance. Maybe if she can flip coins faster than Alice and Bob combined, then she has a chance. But if both of us are using our wagers until Carol comes in, and Carol's not can't flip coins faster than both of us, then she actually couldn't overcome like our bets. She couldn't like win those bets faster than we're continuing it. And she'd have a better chance at winning if she just played the next game of flipping the coins, not if she tried to get 10 head streaks like in the past, if she just tried to focus on the next 10 head streak. And we just included her in that game. Yeah, hopefully that gave some intuition behind proof of work. And yeah, so what is SHA-256? SHA-256 is the algorithm that's used to hash a block. In fact, blocks are like double hash, but part of the SHA-2 family of hash functions designed by the NSA.
Wait, the NSA made it?
Yeah, so
Makes me not want
SHA-2. I mean, what does it matter, right? There's like a whole history of hash functions, and this is a part of this like Merkle-Damgard construction.
Is it open source SHA?
Oh yeah. Everyone knows how this thing works.
Yeah.
No one has been able to find a collision thus far, which is means it's very secure up until right now. So it's a function with no inverse. So pretty much you can't determine the input with just the output in the function definition. So I can tell you what the algorithm is, and then I could tell you what output I got. And if I ask you what input did I put in to get this output, you would not be able to know that. Because it's a very interesting that way. And trying to like reverse engineer something would kind of get you in the same position as just running the function forward. But it's like it's not invertible is what we say. Like there's no way to get this input from the output. So there's no discernible pattern also between outputs given a pattern of inputs. So if I put 1, 2, 3, I might get like 27, 98, and 0. Like there's no pattern. Just because the inputs have a pattern doesn't mean the outputs have one. The outputs will never have a pattern as far as like we're concerned, and that is a good property of a hash function. You want it to be very unpredictable when you give it like random input. And mining. So instead of the game with the coins, SHA-256 is like rolling a die with a whole bunch of faces. And I put these big numbers here. So 202 to the 256 is the space that you could technically like make a hash output to. And to give you some perspective, the number of atoms in the known universe is pretty much smaller. So yeah, 2 to the 256 is like I'm sorry, it's close to that. I'm sorry, it is still more by a little bit. Because I remember I put 10 to the 76, and it's about 10 to the 78, so 10 to the 82. So, but this is the universe. It's definitely more than on Earth. So, because people don't really understand like the scale of exponentiation. When you take something and double it again and double it again, things get very, very large very, very quickly. So 2 to the 256 actually is an incredibly large number that is hard for people to like really wrap their heads around. So you also get different outputs of the function depending on the values used in the block. So you get different rolls depending on the conditions you set, but the same conditions yield the same roll. So the same input will always yield the same output with the hash function. You want it so it's deterministic. That's another favorable thing as a hash function. You don't be able to verify, right? That's what it allows me to do. If I have an output and I give it to you, you can't tell what the input is. But once I give you the input, there is a way for you to verify, right? And that's necessary for like being able to verify blocks as a node runner. Someone who doesn't mind but who runs a node to audit the network. I want to be able to take their supposed input and their supposed output and check it, right? So it's very easy to check once a block is like actually mined that it was valid. So instead of the game finding a specific number, which is near impossible, so it's not like you're finding one number out of 2 to the 256, you're finding like a number in a range. So the goal is to find a number less than a specific target value. So just to recap, when you mine, you take information from a block, you put it into this hash function, and then the output of this hash function has to be less than a certain number, and that number is called the target. And you can determine what the target is, but I'll go more into that, I think. Okay, here we go. The target value and difficulty adjustments. The target value is the value that the hash of the block must be below. So, when you hash, you get this sequence of bytes that can be interpreted as a number. That's why I say, it's like a function. So it's initialized at a compressed value of 0x1d blah blah, which is this other number. So that's a compressed number, and it's stored in every block has this. I don't want to say difficulty. It has a target on every block, and it's stored in something called n bits. And this is like n bits is technically this compressed value, or a compressed value like this. It's not the whole value. Now the target changes approximately every 2 weeks, and changes the difficulty of mining a block based on how fast the mining process was done. So I have this thing. This
average of all the blocks, all the mining processes.
They after 2 weeks they like reset, what this target should be, and now you have
Basically,
to go.
the whole network's ability to do it, or no?
Yeah. It's not. 2 weeks isn't a hard number. It is based off I think it's 2016 blocks, and if the goal is to have blocks mined every 10 minutes, and if they were, it would equal 2 weeks. But if you did it too fast, and you made 2016 blocks within, let's say, 10 minutes, then you have to readjust what this target should be. Right?
So this is a way to keep the 10 minutes kind of
Yes,
average.
exactly. You don't want to make blocks too quickly, because if you make blocks too quickly, every single block you mine, you could take a little bit from the 21 million that should ever be issued. So imagine if we didn't have a difficulty adjustment and it stayed constant, and all of us joined, we could finish mining all of the 21 million within a couple days if we never had adjustments.
So all these elements here, these like Satoshi and original.
Yes,
Yeah.
originally designed. Yeah, so it's a very, very important part of the Bitcoin network. You need these difficulty adjustments because he was trying to time out really have the issuance go over time. He did not want all 21 million to be mined immediately. And and the new target is calculated as this thing. You take the old target number, and then you multiply it by this block addition rate. And then time, the block addition rate is the time taken to actually make 2 weeks of blocks over 2 weeks worth of blocks. So if, you pretty much want to, ideally it would be 10 minutes, right, per block. But if you ever if you mine blocks on an average of let's say 5 minutes, you will have a difficulty adjustment. And the target will, go down, and it will be harder to mine a block. So, yeah.
Does it use the timestamp to figure out what 2 weeks is?
Yeah. So it does use the end timestamp.
Is there anything enforcing people not being malicious with a timestamp, or no?
I'm sorry, can you say it again?
Is there anything we can all set our timestamps how we want, right?
Yeah. Oh, well,
and if we lied, is there a thing preventing us from lying?
Yeah, so we each have a perception of what the time is, globally. And if any of our nodes perceive time is too far away from the block that was sent to us, then we'll reject that block.
Okay.
Yeah, so it does have to be.
Okay.
Yeah.
Is it a proximity thing?
Yeah, as a node, they made some changes to this part recently in the code, but I would kind of query what everyone else's time is, and kind of make an average time, kind of from mine and some other people. I forget what the new changes are, but yeah, pretty much everyone gets to have their own concept of time, and if a block comes and it's outside your range, then you reject it.
So for someone to try to attack it using this, you'd have to have more than half of the nodes. You'd have to do a 51% attack with this.
Right, exactly. Yeah. You'd have to.
And nobody would actually do that. So.
And not all nodes are the same, right? Some nodes are more important than others. For example, if I don't know, let's say Steam used to accept Bitcoin, right? If Steam's node had a time that was way different from everyone else's, and people were actively buying games on Steam with Bitcoin, then that would be a lot more important to the social aspect of Bitcoin than 47% of nodes that no one really relies on. So yeah. Anyway, that's everything here. trying to look. I'm wondering if I made this calculation. Okay, time taken to actually make 2 weeks of blocks was too much. Yeah, I don't know. I'll look over this calculation again. I made this slides a couple months ago. So, I should probably go and update things. So, what is the difficulty? The difficulty is a metric derived from the target that increases in value when it's harder to find a block. So, this target number that changes every 2 weeks. When it gets lower, it means it's harder to mine a block. When it gets higher, it's easier to mine a block. Now you have this thing called difficulty, which is the inverse, because difficulty is like easier people to perceive than this target. And we just say when the difficulty goes up, it's harder to mine a block. Difficulty goes down, it's easier. And the difficulty is like the largest possible target, the easiest number you could have divided by the current number. So like, if the current number goes down, that means the denominator gets lower and you'd get a higher difficulty. And if the denominator gets higher, the current target is larger, then it gets like smaller difficulty, right? So it's a calculation that allows us to make an inverse relationship with the target. So when the target goes down, the difficulty goes up. When the target goes up, the difficulty goes down. How many times smaller the current target is compared to the largest? Yeah, okay, I already said that. It's the calculation right here. So if you ever hear the word difficulty, you can take it at face value. If the higher the difficulty, that means it's harder to mine a block right now. The target is lower. Probability. Okay, so yeah, I added this one recently in an update. So what is the hash rate? So the hash rate, I don't know if you've heard of this concept before, of a hash rate, but you don't actually calculate the hash rate by asking a whole bunch of miners. You can calculate it just by looking at the blockchain. Now the hash rate is the expected number of hashes needed to solve some n number of blocks over an interval, divided by the time it took to mine those blocks. So it's well, what does that mean? The expected number of hashes needed to solve blocks over an interval. And it has to do with probability. So to calculate the hash rate for the last block, you calculate the expected number of hashes to mine that block, then you divide the expectation by the interval it took to mine that block. And maybe that's kind of confusing, but yeah. Or you could just use this calculation at the bottom. To calculate that hash rate, you just take difficulty and you multiply it by this constant. And pretty much there's some math that makes this work out. That's
Where does this constant come from?
there's some from math that you work out. Compliments of Peter Woolley. But the math isn't super complicated, but I did take it from one of his overflow answers. Peter Woolley is one of the core developers of Bitcoin, and he did a lot of the cryptographic stuff in the code base.
All this was all made before they mined the first block.
Well, no, the hash rate computation is something that came about
it came in later
eventually.
on?
Yeah, because people didn't really need to track the hash rate.
At first, there's no difficulty, wasn't a big deal.
Right, exactly. You can do it with your regular computer, so it's people didn't keep track of it.
Was it 10 minutes from the beginning or no?
Yeah, it always aimed for the 10-minute intervals since the beginning.
You can't get the hash rate from the nonce? I guess not.
No, not just from the nonce.
That's just what it is.
Yeah, you need to know what the target is because basically when you have a target, you can get the probability. You can calculate probabilities that you'll hit the target given any given hash, right? And then I can actually give you a number that says, given this target, I can say you'll probably have to take 15 hashes to get something below that target. So that's what the expected number of hashes is. It's how many hashes you'd probably have to make to reach below a target. And this is all calculated off probability, so it's not hard metrics.
The nodes calculate the hash rate?
Yeah, it's a probabilistic calculation. Okay. Nothing to do with...
It's not super exact, but it's almost...
Exactly, yes, exactly. It's not super exact, but it's good enough.
It gives you an idea of the increased hash power versus load.
Exactly, yes. It gives you the general idea where things going. It's all probability based, so you can calculate it all with the blockchain. And then have this slide on the expected number of hashes. Not super important to go over, but I thought it was kind of interesting. So this expectation formula, you increment I towards infinity, and you say it's almost like you're trying to do repeated trials and say, okay, like, what are the, I don't know, honestly, it's kind of hard to explain. So this is the probability that you'll get, any given hash will be below the target, right? Because you have a target full of numbers plus 0. And you have target plus 1 over 2 to the 256 possibilities. And when you're doing this expectation calculation, you're saying, well, what if I got it like the first time? So then the probability of n would be like 0 for that first trial, or I'm sorry, 1 for that first trial. And you're like, okay, well, what if I got it on like the second try? N would turn into 2, and basically would converge to this number. And there's this whole proof that you could do to like see this.
Oh, that's crazy. That calculation is it's like I've seen it.
Yeah, this one's for a coin flip, but like you could use this proof. You could rework this expression in a way such that you could apply this proof and then prove the convergence to this value as I approaches infinity. So yeah. This should be I2. I don't know why I put n here, but like it's parameterized by I, and as I goes to infinity. Anyway, just not something to look at like super closely. I just thought it was kind of interesting. Anyway, the mining process. So there's this thing in Bitcoin Core called generate block. Most people, or I don't know, what most people use, but I don't believe majority of miners use Bitcoin Core to like actually mine. But there is code to do mining related activities in Core, and I haven't like verified, but I was on Bitcoin Talk not too long ago, and former I don't know if he's done any PRs, but former Bitcoin developer Gregory Maxwell, who's like a very smart guy, also says you could still use Bitcoin Core to mine if you chose to. So yeah, anyway, this is kind of an interesting function, generate block. You set the block hash to null. You set the Merkle root to the result of this block Merkle root function that takes in the block data. And then you have this thing like while, and you have max tries is greater than 0, and your nonce is below this max. Oh, okay, so this is something else I could mention. Actually, I might mention it after. Maybe not. So I can mention it now. So this nonce is the thing that you tweak every single time. So you have a ready block, and then you have this thing called like the nonce, right? And the nonce you keep changing every single time you hash. And eventually one of the outputs of your hashes are going to reach below the target. But the nonce is the thing you're allowed to change. Everything else you want to keep the same. But if you recall, back when I was showing you how much space everything took, the nonce didn't take that much space. So you could actually reach this max number. And like when you do, it's like, well, what are you supposed to do? You've used all. Yeah, exactly. And what you could do is increment the time, because the Bitcoin nodes in the network all have like a fuzzy idea of the time. You could add a couple seconds, and like no one would really care, because generally like within some time range that we're all accepting. It might be like an hour and a half. I don't know. I forget what we accept, or the core software accepts, but they give you some leeway. Yeah, and basically, when you run out of nonces, you can increment the time, and you kind of call that like the extra nonce. Anyway, yeah, this example has some limited amount of tries, so max tries, and it decreases the max tries, and it increases the nonce size. And the nonce could be iterated randomly, so I could say, I want to set the nonce to 1, like 18, 45, random numbers, or you could just do it sequentially. So I could say, hey, 0, 1, 2, 3, 4, 5. And in this case, it's like sequential. Yeah, anyway, and then after you're able to find a block, then you try and process the new block. And if it's not able to get processed, then you kind of log this thing, process new block was not accepted.
Is that the block is that the verifying of the block?
Yeah, there's some verification that happens in process new block. So, yeah, and doxing Andrew Toth. I'm just kidding. This is all public information on GitHub. And yeah, this is something called GitLens, by the way. If you ever check out the Bitcoin Core code base, you could click on any line and see people's usernames or names. And then some mining bips. So, some BIPs are Bitcoin improvement proposals, and they're like, I don't know, plans to improve Bitcoin or proposals, right? And you have a couple that are related to Bitcoin mining, and they get people acquainted with looking at BIPs and understanding that people are making proposals all the time. I included some other proposals related to mining here. So the first one was BIP 34 that I wanted to go over. So BIP 34 required people to put the height of the blockchain, which is basically how many blocks have been mined, into the Coinbase. And let me revisit some things. So before you're saying, oh, like when a miner makes a block, you heard they can put some data right somewhere in the block. If you want to put, as a miner, you could always kind of put some arbitrary data within the Coinbase transaction. So typically these are op return outputs. Op return allows you to put a certain amount of data to an output, and you could make the output like 0 value. But one of the things that was actually forked in the consensus is you have to include some of the data related to the height of the block within the Coinbase transaction. But this isn't put as part of the op return output. This is included in, can you read what that part is, Michael, at the bottom right?
I guess it's added here, the script sig?
Script sig, yes. Do you remember my script? Can you tell us what the script sig? It's okay if you can't. It's just
the hash of the script. Was it the added new script? Or?
No, it's like it's where they would put with a regular transaction. That's where you'd put the signature for legacy transactions.
Okay.
So in the Coinbase transaction, you're making an input, but it doesn't really matter what you put in the script sig, right? Because the validation rules of the Bitcoin blockchain say you get these coins regardless. So what signature or whatever data you tried to put in to satisfy a script doesn't matter, because there wasn't a script that was getting the Coinbase to begin with. So you can put arbitrary data in the script sig part. You can put them in op return outputs. But this BIP 34, sorry to get away from this, but this was a soft fork that required the height of the Bitcoin blockchain to be put into the script sig. So
is this recent or like in the past?
it's in the past. It was
way back in the day?
yeah. It was well, I don't know, way back in the day, but let's say maybe a decade ago or something,
Okay.
or less. I can't remember. And then it's in little endian. That's why you see this thing. But if you convert it back into big endian, which is doesn't really matter, and you decode it, you get that number.
What is endian? Little endian?
It's I don't know like a good way to explain. It's a way to read bytes.
Okay.
So typically when you represent bytes, let's say I'm representing it as like bits, then it's a zeros and ones, right?
Yeah.
And the number all the way, let's say the number all the way to the right, the way I want to read it is that's going to be the smallest number.
Okay.
And as you go to the left, that's going to be the biggest number.
That's little endian?
That's big because the first part that you encounter is the big part.
Okay.
But little endian, you reverse that, and you interpret the part that you read first as a little. So it's little ended almost.
The number 123.
Yeah.
It's another way to use crypto number.
Yeah, it's just another way to parse like bytes.
Like if you
or
had the
to
number
understand bytes.
123, we write it 1 and then 2 and then 3.
Yeah.
And here you would just write it backwards, and the computer reads it back like faster.
Yeah, exactly.
321 is actually 123, not 321.
Yeah, it's a different way to read things, and it's honestly kind of annoying that they use little endian. Big endian standard almost everywhere. Little endian is not like
Wait,
super
what's the
common.
Intel one? Is that big endian or little endian?
Huh?
Intel?
Most architectures use big endian. This was like programmed in C++ to use little endian for things, which is again very annoying, I think.
Okay.
So
the script sig was like the input. It's like what the input is telling you.
yeah, script sig is in the input. So
you put like the script you put in the, like.
yeah, you can put whatever you want in the Coinbase because the Coinbase isn't gated by a script pub key. you could always claim the. So yeah, if I paid Michael a transaction and I gated it in my script pub key that said basically it needs your signature in the next transaction to spend, that's because like it has the script pub key on it. But when you create a Coinbase transaction, you could make an input and unconditionally like pay yourself. Like there's no script that was guarding it. The only prerequisite is that the thing that was paying you is in a valid block, and it's the Coinbase for that block. So yeah, basically this is where you usually put a signature for legacy transactions. And instead, for the Coinbase transaction, because it's special, you can put whatever you want in there.
Okay.
Yeah.
Script pub is just where you're sending the money to.
Yeah, script pub, exactly.
But, like, there's a fancy way to write it.
Yeah, so outputs have script pub keys, yeah, and they're like the locking script of your money. Another thing to notice here is they put gibberish. So like you do have to include the block height in a certain position, but after it you could kind of put gibberish. And why might you want to do that?
Is that what the normals want to do?
Well, everyone can do whatever they want. You have to see what mining pool it is, but like, yeah, can you?
Is that where they put the chancellor thing?
Yeah, I think they put that in script sig. But
Like in the first blog, there was like a news headline of like, oh.
yes, but in general, why do you think it's related to the end nonce? This could act as an extra nonce, right?
Entropy for the nonce?
Yes, well, entropy for the hash, yeah, exactly. So you could use the nonce, you could use the timestamp, and you could use the script sig within the Coinbase transaction.
Okay, so if you run out of nonces,
Yeah,
and
then
you don't feel like incrementing the timestamp, you can just mess around with it.
exactly. Just add some bytes to it, and then you're good to go. You have a whole new nonce range. Yeah, kind of interesting, right? So version bits with timeout and delay. I actually don't even know what I was putting here. So sets the default end version value to this whatever blah blah, which is foreign little endian. So this is about the block version. So the default block version was 1. And then when the soft fork came in that said you had to have the height of the blockchain within the Coinbase transaction, that marked block version 2. Now, you had this other thing for signature serialization normalization, and that was made this block version of 3. And then you had this other thing for lock time. When lock time was introduced, you had a new block version that was 4. Now, they ended up repurposing like this whole version stuff, and the rest of the 29 bits after the bits that were used are used for setting the future bits, and are selected from the right. So the bit 2 for Taproot means second from the last. And yeah, so basically I can't remember the exact reason behind this, but they're like, why don't we use this? Look how much space is used for the version. They're like, we could use some of these like version bits to signal like features that we want to go and add. So this one of the bits was turned on for Taproot, for example. So there's this SegWit soft fork, and Taproot is what we call SegWit v1, because the first one was SegWit v0. And when you wanted to signal to people that like, hey, I support like Taproot and everything, then you change something in your version block, in your version within your block, and you say, hey everyone, like I support Taproot. So this is like a repurposed thing. When you have this much data on it, it's like, you just have to make things work, and like you don't want to add new things to the block. It's like, why not just repurpose this? The rest of the bits are manipulated by miners if not actively being used to signal. Okay, yeah, and if there's no feature to show off, then these are also aggressively scrambled for miners. So like miners, they literally will change whatever they can while still maintaining a valid block to use as an extra nonce, because as your ASICs or your miners get more and more powerful, you can exhaust the space a lot quicker than you could when you're first starting out. So you can go through all the nonces pretty quickly. You can go through a lot of different timestamps as we get more and more hash power pretty quickly. And if you don't want to wait for like a later time to get access to more timestamps, then you have to find other things to like mess around with. again, these are like the script SIGs of the Coinbase transaction, and now this is a new thing that they're using. Well, not new, but like this is something else they can use. It's the version. Any things that aren't being used as active features is say like scramble this, and we're going to use this as more extra nonce. Again, they aggressively change everything and anything they can while still maintaining a valid block towards the purpose of finding a hash below the target first.
Is there an order to the transactions in the block? Or no?
There is an order.
Can you change the order?
You can change the order as
Like
well.
people do?
Yeah.
Okay.
But you have to be very careful when you change the order, because who did this recently? They I don't know. They did had some algorithm where they're changing the order, and they had included a child transaction before the parent, and then they made it invalid block. So invalid block. Yeah.
Oh, okay.
Yeah.
I don't know that. So the transaction, there's so the order matters.
Yeah,
The
order
file is-
matters for sure, 100%.
Okay.
Yeah, if you do not want to include a child transaction before a parent transaction.
Is the cost of the block stays the same, $50,000?
Yeah, well, but if you were to take a child and you moved it before like a parent was spent, then it would be invalid, and you'd lose all that 50. So regardless.
So the energy used to mine that block would just be wasted.
Exactly. So yeah, you don't want invalid blocks. If you reshuffle transactions, you have to be very careful on how you reshuffle. So it's like you don't want to change too many things. These are very safe things to change, right? Like you could
Okay.
scramble a lot of the version thing.
I guess I thought the transaction list would be easier because you're not, or like more clear because you're not like messing with old stuff that. But actually no, because you might screw up the order.
Right. The worst thing you could have happen to you as a miner is wasting money on trying to like mine a block that is invalid. It's like very I imagine as a miner it would be very sad, right?
Interesting. Yeah. Interesting.
Yeah.
How long does it take to mine a block? I mean, 10 minutes, right?
On average.
On average, yeah.
Yes, on average. And if you do it too quickly, then
It'll-
these 2016 blocks will go by like that, and difficulty adjustment, right? So yeah. Let's see for the next.
So it's $50,000 every 10 minutes, energy-wise, in the whole network usually.
I don't know what it depends on
that
the
exact number, yeah.
Yeah. The money that they get also is dependent on like how many people are using Bitcoin at that time. So like if we're like spiking up the fees, if like
Oh,
the
okay.
demand is
It's
super
a
high,
fluctuation.
right?
Yeah.
Exactly. So they could make $100,000 in a block, right? Or they could just make like a small fee
very
amount.
small,
Yeah,
okay.
let's say 70 or 60. I don't know what the current amount now is.
Uh-huh.
Just because it's quick, we could actually check real quick.
What's the block reward? I thought it was 6 or something.
Yeah, but it's the Coinbase also includes like the fees as well.
So like in real life, you gain 6 times $70,000.
Yes. So subsidy on the fee. Oh, it's actually a lot
Oh,
higher
so
than I
500,000.
Oh, that's
thought.
super expensive, right?
Yeah, that's a crazy.
The hash rate's so high right now, right?
What I forget the price. There's also price increases on Bitcoin, right?
It translates to the price too.
Yeah, my mind isn't very good at like converting. Like I don't like to look at the price. I like to look at just the Bitcoin amount.
Uh-huh.
But yeah, this is a pretty large number for subsidy and fees. The fees, this isn't actually, these fees aren't that big. They were a lot bigger, a while back.
On
And
average, what, it's like $1
Oh,
and
the
change.
network was
Huh?
very used. It was super
yeah,
expensive.
it's not. Yeah, the network's calming down. Like the demand isn't like people aren't bidding up for block space right now.
So when like the bull in a bear market, when the transaction fee goes higher, right?
Well, in the it depends.
It depends.
Yeah, on like the usage, how many people. It really depends on like the market of what we're trying to do. But I don't know where February is, and I know I'm not going to be able to get here. But like Roz could attest to how high the fees were during inscription period. Yeah, there were.
Didn't
Yeah,
someone
it
say it
was,
was like $20 or $40 or something?
Yeah, you could pay $20 for a transaction easy during that period, especially if you're trying to inscribe like in a specific block number or something like that. But yeah, so these fees relatively are like very low. Yeah, see, it's like 89 cents. Sure, why not? Yeah, you can send $1 billion for like if you had like UTXO with $1 billion, 89 cents to transfer. It's pretty crazy, right? Yeah. So let's go back to slides. And there we go. So, okay, yeah. The version, I'll go to the next one. There's something else called optical proof of work. To some people, like the power used to mine blocks is seen as a like negative thing. So all the power that's used to mine a block is also used to secure the network, because if someone else wanted to undo that block, they have to put up more energy than that block did to get a hash that's lower than the target that block had. But some people don't like the energy use. They think, oh, this energy use is inevitably gonna lead to more pollution. We don't like the mining algorithm, blah blah. So this one individual, who like I don't think subscribes to like the pollution thing necessarily, but he proposed an alternative in a BIP called optical proof of work. And just reading straight from his BIP, he said shifting to a high capex proof of work has the added benefit of making the hash rate resilient to Bitcoin's price fluctuations. And once low OPEX hardware is operating, there is no reason to shut it down, even if the value of mining rewards diminish. So I guess he wanted to make it like so people can't get a leg up in mining, and I guess to have it more distributed and have these devices. I don't know, whatever he said, there's always gonna be problems shifting optical proof of work. There's always gonna be gaming the system. But yeah, high barrier to entry, but M1 Pro is estimated to do. Oh yeah, I was trying to show people that mining actually uses a lot of energy, and my M1 Pro can't actually do that much. It's pretty much nothing compared to an S19. 22 million M1 Pros needed to equal an S19. So, yeah.
Holy shit.
An S9 can do 14 terahashes. So also, look at this difference in performance from the S9s to S19s.
Yeah, that's S9's what we got.
Yeah, and can be profitable with low energy. So if your energy is super low, then you can run an S9, right? It really depends on the energy price, what you pay.
Oh, so it can be profitable to still use it?
Yeah, because you're not trying to mine a block. You just want to get paid for the hash that you're giving.
It's per hash rate.
Right. Well, usually.
If you're going to a pool that's finding blocks and you're sending hash, you'll get a little chunk.
Yeah. So yeah, use about a third the energy of an S19, but has less than a third of an S19's hash rate. It's not, if you wanted to mine and you could dish out for an S19 is definitely the way to go. But if you had an S9 and super cheap energy, then it also makes sense to mine with an S9. It never makes sense to mine with a MacBook Pro. So, and I don't know.
S19's probably
The prices fluctuate based on demand.
Is S19 the state of the art now?
No, they've got even higher.
Well, there's S21s, that are being released. They're being rolled out right now.
Like five, is it 10K?
They're probably 10K.
They all vary depending on the Bitcoin price and the demand for ASICs. So
Right after.
You get an S9 for a couple $100.
I see a T21.
yeah.
Or
So
no, S21, 5,400 bucks.
Yeah, I'd say probably.
well, the prices.
Even at the 10K is what you got.
The prices vary so much that the Bitcoin company I work for, they have this thing called the basic note, which is the security that is the whole thing's predicated on we're gonna collect a whole bunch of ASICs during a bear market, and then during a bull market we're gonna sell them, and then the people who are holding the security will get the profits, and that only works because there's a trend of ASICs always increasing in price whenever there's a bull market. More people are trying to buy.
Oh wait, so they're not actually mining with them? They're just sitting on them?
Yeah.
They're just using them to
Yeah.
block security.
Yeah, exactly.
Oh.
They securitized ASICs, or the possession of ASICs, so that you could sell
I
them.
thought they were mining and you were getting a dividend or something.
There's another security. It's called it's BMN. I can't remember if it's Bitcoin mining note or blockchain mining note, but that's a different one. Yeah, but the basic note was the newest thing that was introduced.
Buy a bunch of mines.
It's a liquid asset?
Yeah, as a liquid asset.
Wouldn't it be good if they turned them on at least for themselves?
Well, then,
Then they get worn out.
exactly. It's what can you actually sell them for, right? Depending. So, yeah. And then I'll go to the next page. Drive chains. Anyone ever hear about drive chains before?
Is that what liquid is?
Huh?
Is liquid a drive chain or?
No. Completely different mechanics. So, drive chains, this is an idea that requires cooperation of miners, and the idea behind these are having a hash rate escrow that custody funds as they're moved to other chains. So basically, you need all these miners to come to an agreement to not steal users' money, and they wouldn't steal people's money because they believe that having playing by the rules will get them more money over time. So miners
So
can.
it's the same game theory that mining has, but for escrow. Miners make more money by not being dishonest.
Maybe it's a lot easier to go after these drive chains than it would be for like actual Bitcoin, because yeah, it's because like how valuable is this other chain gonna be if it's like pegged to us, and why not just like rug everybody? And you don't have to rug every chain. You could like rug some chains, and basically it's like you get like less blowback for certain minor attacks than you would from Bitcoin reorgs. And another difference is you can't really like steal somebody's Bitcoin assuming that you have a transaction that's confirmed. In this case, miners can steal coins that are locked in the hash rate escrow, and they can steal it like, you know, regardless of the confirmations that are put on something. As all of them collectively decide to steal, they can. So some people are okay with the risk, some people are not. It's a huge debate within the Bitcoin community. There's a period where all miners must propose bundles via a form of miner signaling, which are withdrawal transactions. BIP is unclear of how a user will deposit money, but there's a PR for this by Luke Dash Jr. or Dasher, I don't know. Yeah, you know, there's.
Luke Shear.
Let's just say Luke. You know, he's also a very popular Bitcoin developer. With a very unique personality. That's why people love him. And yeah, next one.
Wait, are those other chains also Bitcoin, or can it be like some random?
No, it could be
Totally different.
Sky Doge, right? Isn't that what? Yeah, someone's trying to do a Sky Doge drive chain.
That's
so.
where the active drive chain.
Yeah. So yeah, this other one is, you know, almost done with this. So yeah, this is the last slide. Mining pool extensions for Bitcoin Core. So because mining pools have become a big part of mining, they have started, you know, proposing adding things specifically for mining pools within the Bitcoin Core software. Also, including something into Bitcoin Core does not indicate consensus. You know, you technically could have different implementations of Bitcoin, and it doesn't all have to be on Bitcoin Core. Although Bitcoin Core is the majority implementation that is used on the network. And yeah, you know, things are still being proposed. For example, this is saying, hey, can we change some things in the Bitcoin like core node so that their API responses give us stuff that are more relevant for mining pools, because that's, you know, the change that we've made over time with respect to mining at least. And it also proposes functionality that would allow the proposal and validation of blocks through these RPC commands. And yeah, you know, so they'll allow an individual miner to use maybe a more random node and make RPC calls to it to validate their blocks. So yeah, this is the end of the presentation. I don't know.
UBS 9?
Yeah, UBS 9. It's wrapped up.
Is
So-
the block template the same thing as the header block header?
No, block template has like, I think it gives you the whole block in the response.
Okay, so that's like the whole blocks, like data structure.
Yeah, but you can get it like, or you can get it parsed in n bits. I think that's what this BIP was trying to do. Block template, and we could even look at the BIP. So we could, or no, not the BIP. This is the RPC docs. So if you ever went on bitcoin.org, you can see this RPC.
So all these terms you can research.
Yeah. So yeah, this is something that, you know, you can call on your Bitcoin Core node. You know, as like a developer using the RPC, or someone who's just curious, a technical user, and you could yeah, make some requests on like what the next block should be, and it'll give it to you. So if I was a solo miner, I'd have my Bitcoin node running, and I'd call this command and get all the information necessary to.
Oh, it's just the format. It's just not the actual block, not the shape.
Yeah, not that hex block. I don't think any of these give the raw one, but it gives it in very nice parsable
So what was that bit
properties.
trying to do?
It was going to add
Add a value value, add a thing to it?
Yeah, extra data pretty much. NBits, size limits, Coinbase info, and they might have already added this. I can't remember the status of this, but I think I saw. Well, this has the target, so like the hash target. Yeah, it seems like a lot of things were added. So maybe that one was already completed. I don't know, to be honest. Yeah, NBits. Yeah, it looks like compose target. Yeah.
Instead of having to read the transaction of the coin, like reading the Coinbase transaction, they would have to do. You can just look in here.
Exactly. Well, yeah, you can construct a whole block, yeah, by looking in here, and yeah, it's very useful. Previous block hash and all the things I was telling you about, you could see in here as well. Weight, fee, SIGOPS.
Oh, so if transaction order actually matters, then the Coinbase transaction is actually the first transaction in the block.
Yeah, it should be the
It's
first
listed,
transaction in
and
the block.
It's the first one. Okay.
And if I was gonna show you, but I don't even know if I remember where I wanted to show. But yeah, I usually have the Bitcoin code base here. Not to take up too much more time. Dev VS here might already be open. There we go. Yeah, sometimes you could go and view certain things. I can look up Coinbase and see where in the code things are used. Not here. None of these are very important. I'm just gonna. But yeah, it's the first thing in a block. Maybe it's minor CPP. Coinbase. Here we go. You make the Coinbase transaction, and I wanted to show you where it's added to the list of transactions, but it's somewhere here, and I don't want to bore you, but yeah. But I guess I will conclude understanding Bitcoin's source 9 here. So yeah, UBS 9.
What's for 10?
I don't know yet. So
Okay, so
yeah, I'm open to requests. You guys can let me know if there's something you're interested in, and I will stop the stream here. Thanks for attending. Yeah.
Thank you so much.